LeetCode Problem 235, lowest common ancestor of a binary search tree. Okay, so this problem gives us a binary search tree, and a binary search tree is basically a binary tree that is sorted. Right, so what I mean by that is, if you can see here, the numbers on the left side are always smaller than the numbers on the right side. Right, so here is 0, 2, and then instead of this being the next smallest, it will be over here, right? So it's always on the most left node of the tree that is the smallest one, right? That is smaller than the one on the right. So this one will be smaller than this, which means this will be our next smallest, 3, 4, and then 5. Then we go back to the root 6, and we go to the 7, 8, and 9, right? So that's what a binary search tree is. And basically what it wants us to do is it gives us two nodes, P and Q, right? So let's say P is 2 and Q is 8, right? So it wants us to find the ancestor that is between these two nodes, right? So in this case, the ancestors of 2 and 8 is 6, right? For the ancestors of 2 and 4, for this is 2, for this case, right? Because the rule said that if one of the node is one of the child, if one of the node can be a ancestor, right? So a node can be a descendant of itself. Okay, so nothing too fancy here. The approach I had was to use a just a regular recursion method, right? So let me demonstrate how the function works. Okay, so let's say I am using this as an example, right? We'll pull up my, okay, so I'm using this as an example. So let's say we are at root. So our root is 6, right? Our root is 6. Let me define P and Q first. So P is 2. Let's make it a bit harder. Let's say 0 and 5, for example. Right? So 0 and 5. So 0, P, 0, Q is 5. Right. Okay. Then my root is now 6. So in this case, the lowest ancestors would be 2, right? Because right, 4 can't be an ancestor because 4 is 0 is not a child of 4, so it must be 2, right? Okay. So root is 6. Is root null? No, we don't do anything. Then we check whether or not root is more than P. So right now 6 is more than 5, which is correct. But 6 is not. 6 is also more than Q. Right, okay, so this is P and this Q, and they're both lesser than root. So we recurse to the left, right? So when we recurse, so root now becomes, so we are returning, root now becomes, left is 2, right? 2, okay, and then we compare again, right? So since 2 now is more than 0, but since 2 is more than 0, but it is not more than Q, and 2 is less than Q, but it's not more than 2. It's not more than 0, right? So we can safely uh, deduce that this 2 is the lowest common ancestor between 0 and 5, right? So that happens when, so we return 2, which is the node of the lowest common ancestor. I'll use another example. Let's say something random, like uh, I guess you can use 0 and 4, right? So P is 0, Q is 4, and our root is 6, right? So we return. So first thing we check, is our root more than 0? Yes, Is our root more than 4? Yes, so we go to the left, which is 2. So root becomes 2 again. And then is 2 more than 0? Yes, but it is less than 4, so this is disregarded. And so is this, right? Because when root is more than p and q, we will go to the left, right? Because we want to reduce our root. And when root is lesser than p and q, that means we have to go to the right, because we want to increase the root. Our goal is to stay in between, right? And when that happens, we return the root, which is 2 again, which is the correct answer, right? So we return 2. Okay, pretty straightforward. Nothing much to say. That's all I have to show. Thanks.